In previous cases, we've already looked at a queue and how to build a queue from scratch. Remember, a queue is a first in, first out type of data structure. But what we want to do is look at how does Java implement the queue? And the purist in me is not going to like it, but you'll get a chance to see why and maybe choose if you agree or disagree. Let's go over here in my code window and I'm going to build a queue. I'm making it of type string just for simplicity's sake. Remember, this could be any type of object I want. I'm going to give it a name of queue. I'm going to say new queue. And notice that when I do this, Visual Studio Code is going to automatically fill in some things. But one of the things it's going to do is generate an error, or actually a whole series of errors. And you're going to notice that instead of having the open and close parenthesis for my constructor, it's going to do the open and close parenthesis and then have some braces. Well, you might ask, well, why is that? Well, the queue gives us a ton of abstract methods, things that we have to be able to determine how are we going to implement these. And so if I look down in the problem section, you can see that there are 19 different methods that I'm going to have to implement. And that's what those braces are for. So I probably don't want to do it this way. So what am I going to do? Well, I'm going to use the polymorphic nature of Java in order to help me out. So instead of saying new queue, I can say new linked list. Specifies a string like that, and you'll notice that the linked list, because it inherits from the queue in its internal hierarchy, allows me to create a queue object. So this is kind of a really weird thing if you look at it. Now, if I want to go ahead and add something to my queue, I can specify queue dot, and I might think, oh, you know what? I'm going to use my enqueue. If I start to try to type enqueue to add something to it, you're going to notice that enqueue doesn't exist. In fact, enqueue nor deque actually exist inside of this. So I'm going to have to use the add, and then I can specify a string such as a. Then if I say system.out println queue and run this, you can now notice it shows A, B, C, and D in the order that they were entered. Now you might think, well, maybe that's just because that's the order that you find them in the alphabet. So let's just mix these up real quick just to verify that. Notice I've got D listed twice. I've got a G in there. If I run this, you'll notice that it keeps the appropriate order. So this is using a linked list in order to define my queue. Now you might ask, well, why is that? Well, linked list is implementing from queue. And so it gets all that information, that polymorphic nature, but the queue didn't give us the enqueue and deque. It doesn't give us some of those other types of methods we expect. Just like when I don't have enqueue, I don't have deque, I have to use queue.remove. If I go and print out my queue again, and come down here my console window and clear it so we can see a little bit easier, you notice that it does remove the first element that was added, the A. So this is kind of good. It does work in the right fashion. And you can also see why the purist in me is not liking this. It's like I might as well just use the linked list, and I could if I wanted to. Now, there's another object type that I can use as well. So instead of using a linked list, I'm going to use the array, and it looks like deque is actually pronounced deque. I'm going to specify it's a string, and I can do this. Now this is an internal dynamically sizable array. Notice that it works exactly the same. I didn't have to change any other of my code. This is generally a little bit faster and less memory intensive than the linked list. So a lot of people really like to use this. The other nice thing about this is I can define an initial starting size. So by default, it's like 16, but I could come in here and say, you know what, I know I'm going to need 64 elements. Well, what happens if I have too few elements? And I say, oh, you know what, I only have 2, okay? And clearly I'm adding way more than 2. Well, if I run this, you notice no errors and it shows all 4 elements. That's because, if you remember, I said it's a dynamically sizable array. So you want to start at about where you think you're going to be or how many you're going to need. The queue is great for handling that type of thing, but it does have some limitations because you're not using the standard types of things that you would expect. Now, on the other hand, there's a lot of things that you might not have put into your own queue object if you were going to create it. Like, for example, did you put in a size? Maybe yes, maybe no. Did you have a way that if you used an array that you could grow it if you went past it, or are you going to throw an error? Maybe, maybe not. That's something you'd have to work out. Do you have a chance to peek or to find something inside the queue? No. On the other hand, you have things that are different. For example, I can go in and get something from the middle of my queue. That's something I shouldn't be able to do. I can remove items from the middle of my queue. Once again, something I shouldn't be able to do. So there's some weird things about the Java queue, and I personally get a little bit frustrated by it because of the purity of, how I like to code. Does that mean you can't use it? Of course not. Should you just be using the ArrayDeque or the LinkedList? Probably. Is it going to cause any real issues by not having enqueue and dequeue and having to use add and remove? No, it's not. So it's really a matter of, is this okay for you in your situation? And that's why we study data structures, to figure out, does this work for us? And so that's something to look at. We're going to look at another type of queue in just a minute, the priority queue, and some advantages and disadvantages with that as well.